Hello, learned citizens. Welcome to today's lesson where we are going to explore the scientific method, a fundamental process not only in chemistry but in all scientific fields. If you've ever wondered how scientists make discoveries, test their ideas, or solve real-world problems, the scientific method is where it all begins. What exactly is scientific method? It is a systematic step-by-step approach that scientists use to answer questions about the natural world. Whether you are figuring out the chemical composition of a substance or discovering a new reaction, the scientific method helps to stay organized, logical, and objective. The six core steps of the scientific method are observation, question, hypothesis, experiment, analysis, and conclusion. Step 1. Observation. The first step in the scientific method is observation. In chemistry, observation means carefully watching and recording events. For example, you might notice a color change, a temperature shift, or the formation of a gas during an experiment. Good observations helps us form the foundation for the next steps. It is crucial to take note of everything, no matter how small it seems. Once you've made an observation, it's time to ask questions. This step is all about curiosity. For example, if you observe a color change in a chemical reaction, you might ask, why does this happen? What causes the change? These questions guide the direction of your investigation and help you focus on what you want to find. Next comes the hypothesis, a tentative explanation or educated guess to answer your question based on your observations and knowledge. You propose what you think is happening. For example, you might hypothesize that the liquid turns blue due to a chemical reaction between two substances when heated. Remember, a hypothesis should be something you can test. It doesn't have to be right, it just has to be clear enough to guide your experiment. Now comes the fun part, experimenting. In chemistry, this is where we put our hypothesis to the test. You design and conduct an experiment to see if your hypothesis holds up. For example, to test whether heat causes a color change, we can heat the substance under controlled conditions and observe. While experimenting, make sure to control variables, take accurate measurements, and record all your data. That way, your experiment is repeatable and your results reliable. Careful documentation and attention to details are what separates great science from guesswork. Careful documentation and attention to detail are what separates great science from guesses. Once your experiment is complete, it's time to analyze the data. What did you observe? Did the liquid turn blue as expected? Or maybe something else happened? Data analysis involves organizing your results, looking for patterns, and determining whether the evidence supports your hypothesis. This step may involve calculations, graphs, or statistical analysis to make sense of what you found. In our case, if we find that the liquid turns blue consistently when heated, it supports our hypothesis. If it doesn't, we need to rethink our idea. Finally, we arrived at our conclusion. Based on the data, you decide whether your hypothesis was correct or not. If it was, great. You've learned something new about chemistry. If not, that's okay too. It's a chance to revise your hypothesis and run more tests. Even when the hypothesis isn't supported, it's still valuable because science is all about refining our understanding of the world. This is how discoveries are made. The scientific method has been used for centuries by chemists to make groundbreaking discoveries, from understanding the elements to developing new materials and medicines. By applying this structured approach, chemists can explore everything from the smallest atoms to the most complex compounds. Whether you are working in a lab, studying reactions in nature, or creating new technologies, the scientific method guides us to answer that improve our lives. So let's quickly recap the steps of this scientific method. Observation. Notice something interesting. Second, question. Ask why or how it happens. Hypothesis. You propose a possible explanation. Experiment. You test your hypothesis. Analysis. You review the data from the experience. And lastly, conclusion, where you decide whether the hypothesis was wrong or right. Now you know how scientists use the scientific method to explore the world of chemistry. So the next time you wonder why a chemical reaction happens or how substances interact, try applying the scientific method yourself. Thanks for watching. If you enjoyed this lesson, hit the like button and don't forget to subscribe. If you have any questions about today's topic, let's have them in the comment section. See you next time. And remember, science is all about curiosity.